Hello everyone. In this video, we are going to learn about hybrid parameters, also known as H parameters. And these parameters find extensive use in transistor circuits because these parameters can be most conveniently measured. So that's why. So these are most suitable for transistor circuits. Okay, so why H parameters called hybrid parameters? Means here in this hybrid parameters concept, so one port voltage, let us say V1, and other port current, that is I2, will be considered as dependent variables, and these are going to be expressed in terms of input port current and output port voltage. So these are known as independent variables. Okay, so we are going to express first port voltage and second port current in terms of first port current and second port voltage. So that's why these parameters are called hybrid parameters. Okay, so now coming to the equations, we're going to express V1 and I2 in terms of I1 and V2. So let me write I1 here, V2. So I1, V2. Okay, so let us relate through H parameters. So this is H11, this is H12, H21 and H22. So these are the standard equations for H parameters. So these parameters can also be expressed in terms of matrix. So like V1, I2. This is pretty easy if you follow the previous videos. Okay, so that means previous concepts. Okay, so H12, H21 and here H22 into I1, V2. So in the matrix form also we can express. Now how we can find H parameters? So let us use the conditions. Okay, so first condition, when V2 becomes 0, what happens? Short circuit can be observed. From the first equation, what we can write? V1 equal to H11 into I1. So what is H11 now? This is V1 by I1. Now from the second equation, I2 equal to H21 I1. So now what is H21? H21 is I2 by I1. So under V2 0 condition, we can find H11 and H21 parameters. Now let us go with the other condition. What is the other condition? When I1 equal to 0, that means open circuit can be observed. So from first equation, V1 equal to H12 V2. So H12 equal to V1 by V2. Second equation, from second equation, I2 equal to H22 into V2. So H22 equal to I2 by V2. Now under I10, what parameters that we can find? We can find two parameters under H12 and H22. So look at V1 by I1. So what is this? So V by I, nothing but water. This is under what condition? This is under V2 equal to 0. That means it's a short circuit. So under short circuit conditions, what parameters can be calculated? Admittance parameters. So admittance Y11, did you remember? Y11 is I1 by V1, right? So this can be treated as 1 by Y11. That means short circuit input impedance. In this way we can express. Okay. Now this parameter H21. So this is the short circuit. So this is also under V2 equal to 0, right? So V2 0 means it's a short circuit. So H21 is also known as actually we have to relate. So here I will write, okay, so this is Y21 by Y11. So I'll be explaining this part. Okay, I'll be explaining this part in the next video. So that is interrelations between parameters. Okay, so for a while I'm writing the expressions and please do follow the next video. Okay, so now the second condition, that is I10. So this is under I10. that means open circuit has been happened. So if we relate, it can be related to the Z parameters because it's open conditions. So Z12 by Z22. I'll tell you how we can get these relations. Okay, so this is I1 equal to 0 again open circuit conditions, nothing but 1 by Z2. Okay, so I'll be explaining each and every relation in the coming video. Okay, so don't worry. Now, shall we write the equivalent circuit now? Yes, we may. Okay, so let us go with the equivalent circuit. For our convenience, I'm writing the equations again here. That is V1 equal to H11 into I1 plus H12 into V. So this is the first equation. Next, I2 equal to H21I1 plus H22 V2. Okay, so call it as second equation. Okay, so now let us represent these equations to its equivalent circuit form. So first we should write the input and output terminals and the corresponding voltages and currents like this. Okay, so this is the first port parameters, variables. Okay, so these are the second port variables. Okay, so this is V2 and here is I2. Clear? So now look at the first equation. So first portion, that is H11 into V1. Actually, what is first equation? That is a voltage equation. So where we can find an voltage equation in a loop. So on the first port side, we have to represent a loop. So in that loop, what is the first element? H11 into I1. So H11 will be considered as our impedance. Okay, like this. H11. And look at the second portion. So this is dependent on second port voltage. Okay, so that's why it will be treated as a dependent voltage source. Okay, so why it is voltage source? So if we can apply KVL, we have to get the relation. Okay, first equation should be there. Okay, so that's why it will be considered as a dependent voltage source. Now concentrate on the second equation. It's a current equation, so we need a node. Okay, so as we can see, this I2 is entering, so let us assume this as a node. Okay, so first I am concentrating on this portion, that is H22 into V2. So as we already know, I is equal to YV. So here this H22 will be considered as our admittance. Okay, so this is H22. Now concentrate on the first portion here, that is H21 into I1. So that means it is dependent on other port current. So it can be considered as what source? Dependent source, okay, but current source. So that means if we can apply KCL, then we can get KCL at this particular node. There we can get the second equation. Okay, so this is what? H21 into I1. So there should be a common point for port 1 and port 2. So that can be observed with this reference line. Okay, so in this way we can represent the equivalent circuit for H parameters. So let us solve a problem based on H parameters. Okay, now let me take one of the examples of H parameters. Okay, so like this, let us say this has 1 ohm, 2 ohm, again 2 ohm, and then 4 ohm. Okay, so in this particular problem we need to find H parameters. Okay, so this is V2 and this is I2. Okay, so how we can solve? So before solving any problem, we need to write the equations first. So what are the standard equations? V1 equal to H11 into I1 plus H12 into V2, first equation. Now second equation, I2 equal to H21 into I1 plus H22 into V2, second equation. Okay, so now let us find the parameters. So first, what condition we can apply? When V2 becomes 0, what happens? It will be replaced by short circuit. From equation 1, V1 equal to H11 into I1. So H11 equal to V1 by I1. So V by I unit is ohm. Okay, now from the second equation, I2 equal to H21 into I1. So what is H21? H21 equal to I2 by I1. So no dimension. Okay, so dimensionless parameter. Now under this particular condition, let us redraw the network. Okay, so this is 1 ohm, 2 ohm, again 2 ohm, and this is 4 ohm. Now what happens? V2 becomes 0. So that means we should not disturb the first port variables, that is V1, I1. Okay, now what happens? V2? V2 becomes short circuit. Okay, so in this way the current is minus I2. Now what happens? This 4 ohm is in parallel with a short circuit. So that means we can neglect this 4 ohm resistor. So if we neglect, the equivalent circuit seems to be somewhat like this. Okay, so this is 1 ohm, 2 ohm, 2 ohm. So here is our V1 and here is our I1. Okay, so don't go for 4 ohm. So directly have the connection like this. So here V2 is 0. Here the current is minus I2. Now concentrate on these parameters, that is H11 and H21. So these are in terms of V1, I1 and I2. Since V1 is a supply voltage, no need to do any kind of calculations. So we have to find the relations for I1 and I2. So this can be even more simplified according to our convenience. So this is our V1. Okay, so this is 1 ohm. Okay, so this is 1 ohm. This is 2 ohm. So this 2 ohm is connected across this 2 ohm, no, first 2 ohm. So that's why we can redraw the network like this. This is 2 ohm. So here the current is minus I2. Here the current is I1. Okay, so now how can you tell me how what is the total resistance RT? This 2 ohm and 2 ohm were connected in parallel. 2 is parallel to 2, which is in series with 1. So there you can get some X ohms. Now can you get the total current now? Here the total current is I1. So what is I1? V1 by total resistance. That is V1 by some X. So you got the relation of I1 in terms of V1. Okay, now it is the time to calculate minus I2. Now, what is minus I2? Is there any need to calculate any calculations? No, because in this branch 2 ohm, so this branch is also having 2 ohm. So obviously the current will divide equally. So this is simply I1 by 2 we may write. Okay, so this is how we get the current I2 relation. Now go for the parameters. Now H11. H11 is what? V1 by I1. So what is V1? Don't write any. Keep V1 as it is. What is I1? Look at this expression. I1, that is V1 by X. So V1 gets cancelled. You'll be getting X. Because this is V by I, unit is ohm. Now concentrate on the second parameter. That is H21. H21 is I2 by I1. So what is I2? Look at this equation. That is minus I1 by 2 by I1. So keep I1 as it is. So I1 gets cancelled. No unit for this. You'll be having certain value. Okay, so in this way you can find the parameters H11 and H21. So half of the problem was over. Now we go for the second condition. So what is the second condition? The second condition is when I1 becomes 0. Let us see that case. So when I1 equal to 0, we can observe open circuit. From the first equation, V1 equal to H12 into V2. Okay, so from this H12 is V1 by V2. So since this is voltage by voltage, no unit. So from the second equation, I2 equal to H22 into V2. So H22 equal to I2 by V2. So since this is I by V, unit is mho. Okay, so now let us redraw the network under this particular condition. Okay, so The network seems to be like this. This is 1 ohm, 2 ohm, here is another 2 ohm, and this is 4 ohm. Okay, right. So what was the condition? When I1 equal to 0, that means the first port has been opened now. Now this is 4 ohm, we forgot to write here. So we should not disturb V2 and corresponding current I2. That means second port variables. Now here V1 will be considered as our measured voltage. Okay. So now is there any current passing through this 1 ohm resistor? No. So we can neglect this 1 ohm resistor. If we can neglect, it seems to be somewhat like this. You can directly have the tapping at 2 ohm resistor. Okay, so now look at the parameters H12 and H22. So these are expressed in terms of V1, V2 and I2. So since V2 is the supply voltage, no need to do any kind of calculations. So we need to do the calculations for I2 and V1. Okay, so let us find the total resistance first. So this 2 ohm resistor, again here one more 2 ohm resistor is there, and both were connected in series, that is 2 plus 2. This combination is in parallel with 4. So do the calculations, you'll be getting the some amount of resistance. Now we can calculate the total current. What is the total current? Voltage by total resistance. That means V2 by some X. So we got I2 in terms of V2. Okay. So we'll be using this relation a bit later. Now it is the time to calculate V1. So what is V1? That is straight away voltage across 2 ohm resistor. For that I need current flowing through 2 ohm resistor. So I'll redraw here. So for a while you forget about V1. Okay. So in this way we can assume. So here instead of two 2 ohm resistors, that can be represented with one single 4 ohm resistor. So here the current is I2. So is there any need to apply current division rule here? No, because both the branches which are connected in parallel having the same amount of resistance. So obviously current will divide equally. I am concentrating on this amount of current. This is I2 by 2. So this 4 ohm can be splitted into, okay, so go for the first circuit here. 4 ohm can be splitted into 2 ohm and 2 ohm like this. Okay, so now what is the amount of current in this branch? Obviously this is I2 by 2. Okay, so now what is the amount of current flowing through this 2 ohm resistor? That is also I2 by 2. So therefore what we can write now, current flowing through 2 ohm resistor into 2 is the formula. So this is I2 by 2 into 2. So that means V1 equal to 2 gets cancelled, you'll be getting I2. So you got V1 in terms of I2. Okay, now concentrate on the parameters. Now what is H12? H12 is V1 by V2. So what is V1? V1 from this relation. So we can represent that with I2. Okay, divided by. What is V2 from this relation? That is X into I2. So I2 gets cancelled. You'll be getting 1 by X. There is no unit because originally H12 is a ratio of V1 by V2. So both were oles, so no unit. Now the second parameter, that is H22. H22 is I2 by V2. So what is I2? So don't write anything for I2. Okay, so keep I2 as it is. So by from this relation, okay, from this relation, what is V2? V2 is nothing but X into I2. So now I2 gets cancelled. You'll be getting again 1 by X. But here the unit is mho because this is the ratio of I2 to V2. Okay, so in this way we can find H parameters. Okay, so now we discuss inverse hybrid parameters, also known as G parameters. Okay.